introduce V.
Great. So my full name is Veena, and I work at LinkedIn. Been working since 2 years. I work at, I'll be talking about, it's kind of an odd topic, but I think through the presentation you'll realize which basically I'm trying to convey. We are part of a team called PI, which is a short name for Presentation Infrastructure. We own the infrastructure for front-end, the web, and partly evolving into how we use the same thing in mobile. It's a big group, and I was one other team member here, Jonathan. So just one member of that. I think it's 7 or 8 of us at this point. So we handle the infrastructure, front-end, JavaScript, the SAS stuff that we use for CSS, and a lot of the mobile thing that we're doing down the line will be handled by us. So I think this is what I was trying to say. So we basically do handle all of the front-end infrastructure thing. So just to start with, I'm just going to tell a story about what was LinkedIn's legacy or LinkedIn's history with web application development. My talk may not be as entertaining as the previous person who was delving into what's the way of the front end, but for LinkedIn, it was certainly something that they had to think through in the last 1 year as to what the front end development needs to evolve, because it's been there almost like 8 years, and when it started, I don't think we had so many new technologies, and mobile was not even in the picture. So when LinkedIn is growing, and I think when IPO in 2010, there's a huge set of questions we had to answer. And our team kind of is trying to answer how quickly we develop and iterate and develop these great ideas that we have with the LinkedIn data that we've accumulated. So the story was basically this, there was a company, and then it had to go IPO. I mean, means you have your site up and running. So our team was basically responsible for the scalability part of our front ends. We have a lot of front end features, maybe none of them, not many people if you use it, but we get a lot of traffic. And we have a recruiter product which brings in a lot of money for us. And that's one of the important front-end sites that we always have to keep up and running. So I think first objective that when I started 2 years was basically scaling to the ever-growing traffic. And we traditionally have been the Java stack. LinkedIn's since 6 years is use JVM all the way from top to bottom. And I think scaling was easy. We built a lot of good infrastructure for like parallel assembly and making our service call times really parallel and faster. Alongside, I think we also picked up on the site speed, and we wanted to have, we were getting traffic outside of US, and usually inside of US our site speed performance has been pretty good, but when we go to like countries outside of US, I think site speed mattered to us. I think 3 years are sometimes like our home page and the LinkedIn profile page is loaded at around 3 seconds or 4 seconds. And some of the objectives was to get all of that down. So this was pretty much what the infrastructure team was focusing on. Scaling, keeping the site up and running, and keeping the site really fast. So what's the problem? I mean, looks, everything is great. I think partly we use agents like Keynote to kind of measure, and also I think they develop our own internal user-based performance monitoring. We have a beacon on the page that collects samples of page load times for 10% of the users, and that's where we kind of track how bad the end-to-end performance is. So that includes both the client load and the JavaScript as well as the server performance. So where is the problem? And everything looks good for us, and you might be wondering, what is this talk related to? So the problem was basically since a year and a half, since we went IPO, I think everyone knows it comes with a lot of money. So the company is growing, and I think we're hiring a lot of people. A lot of people means, I mean, we have good ideas, we have great product ideas to build, and that means your front end systems and the infrastructure that you support needs to scale not just to the site, you have to scale it to the engineers. It needs to be intuitive to use, it needs to be quick to iterate on, And there should be less of interdependencies between the back end and the front end. We really don't want the technologies to slow down the iteration that these really young, smart people that are joining LinkedIn. So this is the thing. So site scale and site speed are very implicit at this point for us. Whatever we do, whatever technology we embrace, and the things that we're doing, I'll talk about. Site speed and site scaling is implicit, and I think one of our major focus in LinkedIn in our team is whatever we do, how does it really help us, increase developer velocity or developer productivity? Every engineer needs to have to iterate quicker. So some of the goals of our team basically is, there are a lot of open source frameworks. A lot of people who come into LinkedIn have worked in Python, they worked in Django, they worked in Rails. They worked in all of these cool things that are great for startups, and they're great for companies who've just started like a couple of years back or like 2 or 3 years back, and they embrace all these cool things. And those frameworks are easy to iterate on. I mean, and they can build stuff. But I think getting to that concentric circle of where you have site scale, uses framework that actually scales, and you also do good performance, and as well give them a tool to develop really, really fast is not an easy goal. I mean, and then I'll talk about that why. But underlying, I think, whatever we come up with, and I'm going back to the talk the previous presenter said, I think we don't have to over-engineer a system. Simple things to develop a simple web page, to develop a simple feature, to develop a LinkedIn profile and add a few features. It should be simple. You shouldn't be, need to understand a lot of the proprietary LinkedIn stuff or a lot of the proprietary LinkedIn frameworks we have. So the goal was this. These are 2 goals: help them build quickly and help them iterate faster. And the LinkedIn history of, I think, 6 years, there's been so much proprietary stuff. We have our own, LinkedIn framework for developing front ends, which is very surprising to many people when they come in. And even the term JSPs is not really like the standard JSPs we used to use. We have our own LinkedIn JSPs. So every web developer who came in or every front-end engineer who came was excited about the scale and the impact that they can have on LinkedIn. And then the second day they see there's so much stuff to learn. There's so much stuff that no one knows about. It's all buried in like the heads of a few people in the company. So those were some of the things that we were tackling. And then the fact that we used Java heavily, it was kind of convenient for LinkedIn to even have a front end in Java. But I mean, the downsides of it being it's not a dynamic language, and then every time you write some code, you have to redeploy and build, and the whole process was slower. So we started thinking about how can we improve that, and the big debate started. Why don't we move into dynamic languages? So this is the next step that evolved into, right? We ended up having languages like JRuby to do front ends because we still want to do JVM, the fact that it can scale, and we already have infrastructure support to do that. Then there were teams that kind of started getting Rails, and because it's dynamic and you can iterate. The mobile team started using the Node, and we use that. So this switch was good. Every team kind of iterates in their own pace using the kind of language that they want to. They build front ends, and it looks great. It's a great story. Did anyone see bad pattern here? At least for the company or for an infrastructure team? Exactly. It's even worse than that. You're like a team does the same thing once, twice, thrice. It just goes on. And tomorrow there's a Mysterio framework that might come along, which we don't know. It might be the awesomest thing, something that I just saw in the morning, the Meteor thing. And the company wants to just use it. I mean, there may be 2 people who join the company who want to just use that. So it's good to, it's easier to kind of iterate with these really cooler things. But I think you also need to, for a company such as LinkedIn, that you need to scale and make sure that it scales to the 160 million users that we have down the line and all the mobile traffic. It's not like an easy switch. So all of these things that we started doing with JRuby and Rails and Node, I mean, there were certain applications. I mean, one of the goals of LinkedIn has been to go mobile, and then, I mean, that's probably the goals of a lot of companies, is, you develop once for both the web and the mobile. I mean, you don't try to do it for mobile once and then web once. So all of this that we were doing was not even fitting into our future goals of, like, how can we iterate fast but also develop to different environments. And another thing that we've noticed with using JSPs or like using Ruby apps or like the JRuby apps or the Grails is like we were doing and repeating a lot of things again and again. One team builds a component in Grails using JSPs, and somebody wants the same thing, but they can't because across these languages, you really can't use these templating languages. And that's where we really started thinking hard. Even like you won't believe we had JRuby apps embedding JSPs. So that's the bleeding edge we went into where in order to just reuse some of our infrastructure, we had one app embedding views of the other. That means a lot of infrastructure support had to be done. We don't know if it's going to like continue to do and how much we can gain from it. And the bottom line is I think we were sent out to solve one problem of like productivity or velocity for the developer, and I think we created more problems, much more difficult for the company in the long run to handle. Because if you roll out one new front-end feature, you have to do it like across all these stacks. And isolating them into one is never easy. So, and that's where I think in the last year, we, as part of the PI team, we focused on a little bit of what we did. And to us, I think it was not that we wanted to reinvent the wheel and come up with a new solution. All we had to do was sit and then look what everybody else was doing and kind of get the best of what we think suits LinkedIn. So this is what we ended up unifying our stack. At the end of the day, in the last 1 year, we have built a lot of infrastructure support. So the first thing was basically, let's unify the views. Let's not use JSPs and ERBs and GSPs, and we can let people use their own front-end stack because they have a lot of applications that they build, and the migration is not a goal for everyone. You want to get the business rolling. So the idea was at least there are very lightweight JavaScript templates, and that's where we think that's where the real, the reason we ended up moving to JavaScript templates. And I think we did tons of evaluation on the tons of templating languages that are there, and it didn't seem like we had to write another one. So I'll just talk a little bit more in the next few slides on what we chose. And the biggest benefit of these things has been the fact that these templates are CDN cacheable. And that's a great site speed benefit for us too. We have quite a bit of heavy pages. I mean, as I said, the Recruiter app that we actually is pretty prominently used in all the LinkedIn profiles that we get quite a lot of traffic every day. They're pretty heavy pages. And the idea was you move to JavaScript, you render them on the client. And the reason why I say write once is the JavaScript templates also have a beauty of you can render them on the server if you have infrastructure for them. On the server, you can run a JavaScript engine on the server, something like Node or something like V8. And you can actually reuse the same template to either render on the client or on the server. I think Twitter just came about that, and then it calls it conditional tier rendering. I mean, that's probably the new lingo. And that's what we adopted. I mean, because there are cases even in like the profile, there are SEO pages in your LinkedIn profile that have to be kind of rendered on the server. But we end up writing them only once in these JavaScript templates. So people now don't anymore write proprietary LinkedIn JSPs or proprietary views of LinkedIn. They just use these templates. The second important thing I think was more than the JavaScript templating. For us, we standardized on having JSON as the data transfer protocol and not HTML. So tomorrow, if we want to migrate to a new, as I said, a new app that is faster to iterate and develop on, all that we need is to send JSON from it, and then we can still continue to kind of use our existing templates. So we can plug and play, so we're not tied to a particular thing like Rails or Node or Grails or anything like that. So it's basically one standard. And the biggest, another biggest thing is like in front of all these front ends, we have an evented server that gives us the performance that we need. So it's kind of a UI or a JSON aggregator. Basically sits, talks to a bunch of apps, and gets JSON from different apps and then renders the page. The fact that it's evented gives us a great performance boost in terms of out-of-order rendering and able to kind of control what pieces of page can be dropped, kind of gracefully degrade. So these are some of the things that really help us in achieving what we want from performance. And again, you just have to scale this one system, and I think it's easy to do. So none of the JRuby apps or the Grails app or even the old Java apps that we have to worry about these things. So a little bit about JavaScript templates. As I said, there's so many of them. I think we have already around 26. All basically two or three big categories. One of them fall into the logic class. I think a lot of people have talked in the beginning in this team of mustache and handlebars. And there's another thing we actually came about during that time called dust that we use in LinkedIn today. It's very similar to handlebars and gives you a great performance. We've performance tested it and we've been using it in LinkedIn and some of the pages. And it's great because it's pure JavaScript. It's a template that's converted into pure JavaScript at build time, and then it allows us to really get good performance. And I think the goods of these templating languages, as I told you, is that it's less logic. We don't really believe in logicless, actually, but we chose this, and I can debate about it. And I know the previous presenter was like, handlebars like basically screwed up the mustache logicless thing. But to our use case in LinkedIn, we have such variety of use cases. It's not a single page for us. We have like 6 or 7 big apps, different domains. One is very consumer-focused app, and then we have a very recruiter and enterprise-focused app. And we have and then we have the mobile app. We have different kinds of requirements for each of them. And I think we chose less logic. I mean, that's what we do use helpers to kind of do logic, but mostly rendering logic and not like business logic. But trust me, it's not much better than writing a JSP or a URB where you can actually clunk in any kind of Ruby controller code or a JSP controller code into that. That's basically what's this. So this is new. A lot of startups and a lot of like small companies want to use it, and they use it. But for us, I think as a company, we have so much infrastructure that we've built even with presentation. None of the stuff like localization and I18 and how would you do with this client rendered template was clear. There was no out-of-the-box solution. And it's good to say that we're going to do client rendering of templates, but when you have like scaling and all the requirements of SEO, and sometimes you won't believe LinkedIn has a good amount of like 5 to 6% of no JavaScript users that we still want to support because some of the products are enterprise. So we just can't say that we're going to do client-side rendering all the way. So those were some of the challenges you had to take care of. So typically this is, in a core example, it's too small, but I'm sure like most of you know about what it basically is. You have JSON as a data, and you write a dust template, which is kind of the same as mustache syntax. It has a single curly brace instead of a double curly brace. It has support for a lot of templating constructs that other languages have. And that's something that I'll go through a little bit. But the good things is like it's quite simple for simple things. No one really needs to understand all these complex helpers and everything that I talked through to write a simple page. It's on GitHub and it's open source. It was written by a person, and then and that one person basically built the whole thing. And it supports a lot of good things about reusable markup you could write. You could write the concept of being dry and not writing the same thing again and again. They're called partials. And you can do conditions, and you can actually do loops inbuilt into it, so we didn't have to really extend too much of it. There's concept of usually when you have views, it looks really simple for simple cases, but there's a lot of reusability aspect comes in. You have to have some way to inherit an existing template or and use some of the stuff that it already does and override a few things. All of these things are pretty good in this templating language that we use called Dust. And that's a code snippet of actually basically looping through a list of people in the JSON and calling another partial. I don't know if people notice on LinkedIn.com, every single profile has a small icon in the top that kind of tells whether it's your first degree or a second degree connection, or is he not connected to you. And that small piece of thing is used across in every single LinkedIn page where the profile is shown, be it on the search listings or the actual profile listings. Things like that, I think we want to do it once. And that kind of support we looked for in a templating language where, you can dynamically kind of figure out. So distance there, if you look at that syntax, is basically distance is coming from JSON. And based on the distance values, and LinkedIn might be a 0, 1, or 2, you can actually have one place where you write these shared piece of components, and then you can include. So Dust allows that by default, and we didn't have to do too much work, and then we chose it, and it's worked great for us. Second thing is, I think this is a debate about logic versus logicless. I think we settled down between the two, and we call it less logic. We try to do very minimalistic logic. But there are cases where sometimes you want to, based on the data, you want to like have a certain CSS class selector rendered. This is not something that we think should be done on the server or on the controller because the data that comes down from the controller is very pure, could be adapted to a mobile template, could be adapted to a web template, could be adapted to another device template. So we really do not want such kind of data coming from a controller or have even logic in the controller that does this. So we chose to write a few helpers, which are like basic logic. You know, you can check if it's, so here is a simple thing that I just cooked up. What it does is, I think based on the distance value in the JSON, it's printing out an IHNized or like a localized text. If the value is less than or equal to 1, it kind of prints your first degree, and if it's greater than 1, it just prints your second degree. And you'll see these at syntax all over in the templates that basically are JavaScript helpers. And you can run them on the client. I mean, as the template renders, this is another piece of JavaScript code. You can write anything that you can write in JavaScript. So this gives full control to the actual developer to kind of build their own, library of what they want to do, like a helper library or a formatting library. And we've tried to restrict it to the minimum most, again, to make it so that we don't have one-off helpers in the whole site and create a lot of confusion. So some of the things that here, again, you want to render a form, so you can create a nice helper tag in Dust, and then basically everybody uses that, and then they don't redo the same thing again and again just to render a form and some of the stuff that have to happen with the form. And this is very clean to me because there's not much, there is very minimalistic logic, and it is devoid of any server-side logic or any kind of language-specific thing. And this is where we are. And to me, these helpers kind of be, since you're plain JavaScript, as I told you in the beginning, there are cases where we want to really render the same template, the same helper on the server. I mean, because it may be an SEO page. Something like a public page, written ones can be rendered on the server too. Since this is all JavaScript, if you have a very high-performing JavaScript engine running on the server, you can just render the same template and just shove out HTML down the wire, and then it just works. And then that's basically a strategy being. And we've rolled it out to a lot of apps in LinkedIn. There are some out there already in production and some in the process of building it. And I think in the beginning when we set out, there was a lot of hesitation on whether something like this, as simple as this, can really help the 6 years of work that LinkedIn has done in building the presentation infrastructure using JSPs or ERBs and other server-side languages. But in theory, actually, that was proved wrong. And I think we've been using it, and it sufficiently scales and works really well. I mean, some of the views that we have is really clean, and it does what it's supposed to do. So this is the next slide I want to move on. I mean, everybody talks about client rendering, client rendering, client rendering. It's not always true. I mean, not every use case that we have in such a big company can always categorized as a client rendered thing. And I've been talking through my talk a little bit of what are those use cases, like you can have an SEO page and a non-JS client that you want to support. But there are also other cases where I think with the biggest thing that comes with Dust as a templating language is you can always pre-compile it into JavaScript on the server. What we've seen is almost like a 10x difference if you try to compile the whole thing on the browser and then try to render it. It's a huge difference. So Dust came off the boat with this pre-compilation step that we do at build time. And we send these templates onto the CDN. They're cached. If you can look at the source code of it, it's basically a anonymous JavaScript function that kind of just converted your template into a JavaScript, multiple JavaScript calls. So when rendering happens on the client, it's basically executing JavaScript. So it's pretty clean. So someone writes a template in the language, and then it gets compiled into a JavaScript, and then you CDN cache it, and then we don't even inline those templates in the page. We benefit from actually caching every single template inside it. Second thing is, why do we don't do everything on the client? These are some of the questions we stumbled upon as we started rolling this out to a lot of features and using it widely in LinkedIn. Most often, a simple use case, you may not even have a sub-template or a sub-template in Dust is called a partial. Very simple. You have a loop. Most of the code examples that actually have on the site are very simple. You have a loop, you list through them, and then you have a condition, you check them, and then you write them. It doesn't really, that a real use case? No. In real use cases, you have so much stuff that goes on, and it's nice to structure them out into reusable stuff. But the biggest thing is, when someone tries to render them, they have to manually have this process of including every single template and every single template within that template that they need to render. That kind of thing is, again, hinders the productivity, or even like, makes it much clunkier for a developer to understand, what are the different templates that I have to download to even render this on the client. And doing all that in line on a page means you're doing it while rendering, and again, it hinders a lot of site performance. And there are cases you can lazy load them, but not always. When you're trying to render a page that you want to immediately show something and not wait for another fetch of that template to be done on the fly, you want to think about that. So we do certain things like this on the server. And I think I'll talk about briefly about the solution and what we do. So this is another use case where, even with client rendering, you may have to do things on the server. So another important thing that also we came across was, before I get into this use case, I'll talk about how we solved the problem of trying to do this on the server. Dust is a PEG.js grammar. It's a very simple, freakingly simple grammar. It's super easy. And all it does is basically exposes you in a way to write a visitor pattern that you can build an AST and then walk through the AST and do whatever you want. You can kind of visit every node, be it a block node or a partial node or another reference node. It's super simple. So what we basically ended up doing is using it not just for rendering, but also for pre-processing. So we write our own walker that build time walks through, figures out the dependencies of the templates, and then gives them, but before the page is actually sent down into the browser, we also send it down a list of templates that it includes, and then boom, you download them way before the template starts rendering. So this kind of a simplicity in a grammar that you can actually write another visitor or a walker and get an AST out of it and pre-process them gives us huge benefits on trying to do some things that you don't want to do on the client. Client rendering is good, but certain kind of pre-processing is good to be done before, mostly because you don't know what kind of client you're serving to. We serve a lot of IE7, IE8 clients, trust me. And those browsers may not be even good at doing client rendering. So these are the things that allow us to actually control at what point we do client and what point we can actually help the client rendering to be faster. Another important thing, I think most often, like simpler sites have very less emphasis on localization and formatting, but we call ourselves the professional network, and I think we do seriously have to consider someone's professional name. And there's certain languages that we support, like in Japanese and Korean, and other languages that we're trying to support. Formatting is a big deal, and we have our own in-house library that we do. And some of the reasons are very very privacy thing as well. There are certain rules that we try to hide certain last names, and it brings in a lot of money. So we can't take some of this logic that we have and put it down the client. The biggest hurdle for us is we just can't expose some of these custom logic that we have to do these things. So in a simple way, a simple example that I'm trying to give you is all you want to do is format a name, a LinkedIn name. Seems very straightforward. You have a first name, last name, and you could do something in a JavaScript in 10 lines, download it, and then be done. But in LinkedIn, it's a little more complicated than 10 lines. You have 21 different languages or more. And there are certain kind of business rules sometimes that apply when even formatting a name. Do we shove all of this down to the browser? I don't think it was a choice that we could do. We may at some point, but at this point we couldn't. So these are some of the other use cases where we can pre-process this template that we have, because we have the grammar, we have the AST that we can build in, kind of replace. So we still build all of these as tags. So as an end user, like a developer who's trying to build this template, is agnostic of what's going on. So if you look at that example there, I don't know if it's clear, it's basically a formatter tag that we come up with. It's a helper, but right now, in this case, if it's prefixed with an SS, it's a server-side processed helper. It's not a client-executed helper. So we just namespace these helpers, and we have a bunch of them that basically do all the processing of that data, and then create something that we came up with, this like template-driven contextual JSON. So there is the raw data that the services usually send. For instance, if I am the LinkedIn profile, my first name is Veena and my last name is whatever. And then I have a bunch of other raw data that comes back from the service. Along with that, they actually want my formatted name, and they want an I18N localized string. They want to display a bunch of other derived data. So for all of that we really can't do on the client, which for some, as I said, for reasons explained, we try to do it very seamlessly. So a developer still writes a tag as it is, and we process them and insert that formatted name into the context that they've defined in. So in this case, it's an array of people, and I think there are 2 entries here. One's Joe and Jade. And Joe and Jade came back as raw data, but the one that's highlighted in blue is something that we processed on the way back. It's like an intercept your data that's coming back from your control, like your Ruby app or your Java app, and then you insert this additional library data into it, and then you send it back. So you're basically avoiding a lot of rendering and like the helper processing on the client for certain clients that don't have so much bandwidth to render, and then the JavaScript engine is slow. We usually hugely benefit from this kind of thing. So again, to us, since the whole grammar was open source and everything, writing something was like this was pretty trivial. So last part, as I said, before we move into the last slide, as I said, we have a lot of use cases. We have SEO. We have certain payment processing pages that LinkedIn uses. They're pretty skeptical of using client rendering because the downside of client rendering is good that you can do all in the browser, but there's very minimal tracking that you could actually do. What happened in Brazil or what happened in China, whether the page really got rendered, was there a JavaScript thing, or is the site performance bad? It's hard to track these kind of things. And those are kind of pages, or those are kind of use cases I think we kind of outright say, no, we want server-side rendering. But since we said that we're going to write these templates once, we did not want developers to learn 3 different kinds of templating languages, right? One that renders on the server, one that renders on the client. So we ended up integrating a V8, which is the Node's or the Chrome browser's JavaScript engine, which is pretty good. And we do server-side rendering when we have these use cases. Certain cases, as I talked about, is like there's no JavaScript. You basically do a no script, and then you redirect, and then send it back to the proxy. So let me go back to the next slide, which actually is a minimalistic, end-to-end diagram of what our front-end architecture today is. And the UI JSON aggregator /V8 is the one that actually renders the same template. So a template basically, or a LinkedIn page, has a bunch of these modules that are reusable. So, something like Profile can develop a lot of these modules that could be reused on homepage or reused on the Recruiter product. And those templates are kind of aggregated together by this unit that sits in front of all of these front ends. So if you remember my few slides back, I was basically having JRuby and Grails and Node. Currently, it's not in front of Node, but other apps, we're trying to use this, where you give this once. If an app decides to do a full server-side rendering, you can actually use the V8 engine and render the whole template and shove HTML into it. And there may be reasons where we have low bandwidth, we can determine whether the latency is really bad or the bandwidth is bad, and we automatically revert back to server-side rendering and not wait for the client rendering to happen. So that is the unit we're working actively on that gives us these kind of benefits once for all the LinkedIn. At some point, maybe even for mobile. Because all of the mobile today that we have in LinkedIn is very up, and they're WebKit only, and then it's predictable and stuff. But I think down the line, if you move more to HTML5, and then we also support non-smartphones, there are always cases like that we want to take care of it right here. And as I said, we have one repository that kind of serves our templates, and that's where, sometimes when you have to server-side render, you talk to the system that stores these static assets and then renders them on the server and shoves them back. So this is pretty much what you're doing at LinkedIn at this point. And I think this is a system we're trying to evolve, and kind of even the V8 engine is a plugin to one of the really high performance proxy that we use. It's a reverse proxy called ATS, which is developed out of Apache, I think Yahoo. It's an Apache project called Apache Traffic Server. So we use that because I think a lot of in-house expertise exists. And V8 is kind of integrated into that C++ engine. So that's another module that's open source for anyone to use who use ATS. And lastly, there are a lot of pages. This is one sample page that if you go to linkedin.com/people/pymk, which actually shows you a list of people you may know uses this at this point. We use Dust and templates and JSON and rendering. And fact that this is my last slide, and I would just want to conclude. We actually do a lot of Dust. It came as started as a prototype, and then I think a lot of the teams in the company have embraced this, and it's given a huge productivity boost because the biggest gains that I think I want to highlight at the end of it is we have a web dev community that we do front-end stuff, basically develop features. They were very much reliant on a server-side technology, like they had to know Java or they had to know Rails or they had to know some kind of language to even finish up the end-to-end product. Today, all we have is support for building the whole JSON using mocks. So we build mock JSON, we build these templates, and then actually build an end-to-end feature on the app without really having a dependency on the back-end engineers. And that's where I think our major goal was to begin with in the last year is how do we really improve developer velocity at LinkedIn and make it pretty seamless and try to use as much less proprietary LinkedIn technologies for doing that. And unfortunately, the person who developed Dust, we love it, we're using it, and we've done a lot of it, is not accepting pull requests. So we went out and then we forked ours and we maintain a fork. I think we're collaborating with PayPal. We went there and we spoke. So I think we're trying to actually see if we can have a broader community embrace this. Because compared to small startups, I think LinkedIn and PayPal are companies that have huge legacy built into them to actually embrace something like this new and also make it just work like they worked with the older technologies. And we have a couple other things since we moved a lot to JavaScript templates, similar to the backbone. We're trying to, again, it's all on GitHub. It's called Loo. It's like another framework we're developing for event-driven, handling event-driven controls on the thing, which I don't personally am part of it, but I just want to put it as a plug that this is something we're doing. And we also have the dependency management thing. I think I heard a nice talk about Raptor in the morning. We're similar kind of thing doing with LinkedIn too. So the idea being is to move more to the browser and then be very smart about when we render on the browser. And that's my job. So certain pages, I think we are predetermined because we know it's basically an SEO page. We have certain apps already configured to say this is an SEO page. And otherwise, if you don't have a user agent, you basically do a redirect and try to render them. But most of the SEO pages, we pretty much know that it is supposed to be a crawled page. So we pre-configure them to do server-side rendering.
So you have a separate SEO page versus what you listed?
Not exactly. So it's the same template. So that was the whole idea of write once and render either on the client or the server. So if you pre-configured your particular app or page to have SEO requirements, then we never try to client render that whole page. We always render it on the server and send HTML back to the bot or any of the engines that are crawling.
How do you whether to use the client render versus server render if you don't know who's calling it?
As I said, some of our pages are very predetermined. So we have very public pages, like the LinkedIn profile has a LinkedIn profile page. But as I talked about, there are reusable markup that you can write, right? I mean, you can use the same reusable stuff in a public profile page as well as a non-public profile page. There is code sharing.
And the question is, the bot can request your non-profile page as well. You can request your other page as well.
Oh, I don't think every single page we care about crawling. I mean they could. It doesn't really affect our numbers, I guess. Yeah.
So one question I have is, if you use client-side rendering, let's say you have a bunch of items and you're looping through and executing the rendering at the client side. If the browser does the rendering, it has a natural process of browsers are very optimized for rendering these big pages, whereas your JavaScript is going to go loop and it's going to put a freeze effect for the user because it's too busy executing JavaScript.
I understand. I think so. So we try to limit those helpers. I think that's where you're coming and talking about helpers that we use for certain kind of rendering logic.
Not only that, but just you have snippets of a bunch of UI elements that you're trying to append to a page.
I mean, there's a page. Like a reflow happening. You're saying?
Reflow is you could have let's say search for something and then you have like 100 results.
So again, a lot of that is kind of configurable, and when you kind of embed these things, whether you have above the fold elements that you don't want to like break them into multiple modules. So it's something that we can render right there and send the above the fold stuff server-side rendered. But below the fold stuff, sometimes like the infinite scrolling we have on pages may not be a case for server-side rendering. So we try to see how much of that can be managed between server and client.
So when you're asking them code, you kind of have to figure out.
Declaratively say sometimes that, yeah, part of this page, it's a big spec that we have. It's again a part of the page that you write. You can say a certain markup is server-side rendered. So that kind of gives the proxy server that we had in the thing a directive saying that I'm going to pre-render this and send it rather than trying to render it on the client if performance is a reason to do that.
So did you try to normalize the data access APIs because accessing data that you need for the templates from a client can be very different from on a server? Did you have the same kind of API?
So that's the part that I was talking of. Our APIs, we want to use internal and external APIs the same. So our external APIs don't give all this formatted data, and like date formats and time formats are never done there. I don't know if I'm...
The actual client itself, like the actual making the HTTP request to get the data and then passing that to the template. You normalize the template part, the view part, and then the other part of actually getting the data and the controller, did you normalize that as well across the two environments?
You mean across the two when you say two? The
server and the browser.
It's actually the same. I mean, why would it be different between the server and the client? Can you talk about a use case?
So if you have an API that you want to make a call to get some data, if you're in the node, you don't use necessarily XML HTTP request to get the data. You might use a different API. You might use the native HTTP object. And then in the browser, you do use XML HTTP request. So did you just create wrappers around those differences?
So I think one thing that's kind of not very clear is the UI aggregator that we have. We really don't make XML HTTP requests to render these modules on the page. The proxy that sits in front is kind of doing internal data center calls. So it's not from the browser. It's not from an XML HTTP request they're making. But certainly there may be cases where, between like an AJAX call or XML HTTP request to the base page to be rendered, there are differences, and I think that's more handled on the controller. I don't think we have like solved it in a very frameworkish way, no.
Okay.
How do you debug these templates for any compilation errors?
So they're all on the Firebug console output. So it's basically, as I said, they get precompiled into JavaScript. So if there is a syntax error while compiling, we have tools to do that while on development. It gives you a good error reporting what line number and what syntax is wrong. But on the runtime, if there's really something wrong, it's just a JavaScript error. So that's the side effect of like using JavaScript. You have to be like really testing it. So it blocks the rendering of the entire page if there is one single error at the top.
No, but in some cases, suppose the data is wrong, but it is not showing any JavaScript error, but the page is not coming up nicely. Data is not there. So how do you debug those things?
These templates, as I said, they're very forgiving. If the data exists, they render. I think that's the concept of all logicless templates. If the data exists, they render. If the data doesn't exist, they don't render. That's the part, as I said, it's hard to do client-side tracking in those cases. So good testing around it. Mock JSON helps us to kind of build good test fixtures on different kinds of data.
I guess the point that we're trying to make is what you write is what you're not debugging. What you're debugging is what's produced by the framework stuff.
So it's hard for a developer to find out where the problem is next time.
It's a compiled template is the same as what you wrote. It's just the JSON that's kind of augmented. So maybe if it's not clear. So we don't really change. So we just allows you to write a template and kind of converts into a JavaScript just for performance. So nobody can really look at I mean, you mean to say is it hard to debug the JavaScript thing?
No, I'm not saying that. What I'm saying is that you write some code, when you're actually debugging it on the web page, you're actually debugging it in code.
It's a compiled code. Yeah, it's a compiled JavaScript. Yeah, you're right. And most of the time we haven't seen that because, as I said, it hasn't been a big concern because most people who develop are very JavaScript friendly and web developers are. And the exception handling in it's very forgiving. And we haven't seen a use case where people complain about that hugely.
So,
Yeah, I'll take that person's because I know he's like usually hates logic templates.
So I don't know. You mentioned that you use right there
So basically we test it on the browser. So that means our pages automatically download this library of helpers that we have at the top way before any rendering happens. Yeah, so that's part of the framework that the bootstrap data that we have has these helpers and the basic bootstrapping we need to render.
Cool. So you have like a separate build process or something that's like, you dummy JSON over here?
Yeah, yeah. It's sometimes through a header, control through a header or a URL parameter, like you have a page. We use a simple thing called mock equals a mock header, yeah.
That's a good idea.
Because you're not waiting for the entire service to be ready to actually even build the end-to-end feature. Yeah.
So back in one of your earlier, you don't necessarily have to go there, but you had the less than equals, less than, and it seems to me like you were trying to avoid having an expression language at the expense of adding a bunch of tags that give you basic expressions. Do you think that's actually going to scale to all types of applications? Because you're basically inventing a new language on top of those, on top of HTML. But you see what I'm saying? Is it?
The two things that I could answer, it's one thing, it's Dust came with that helper, so it's inbuilt into Dust. There are certain helpers, so I would say it's not a new language. But I agree that the fact that we want it to be logicless and we're adding these helpers to do, I think it was just a bridge you had to, or it's a marriage of things that you have to. Usually every use case doesn't fall into pure logicless. For instance, there are applications that write using Node, and they do some of this data munging right in the Node and then give back a very usable JSON. For them, it doesn't really make sense to use this kind on the template. If you're not working in a job, so I mean, we're talking more about developer velocity and not to depend on certain people. As I said, the mock JSON has really helped us and tried to reduce this kind of logic. There's a use case where somebody had to wait for an engineer to write an endpoint that gave them the kind of JSON they wanted. Now with mock, they actually do that by themselves and tell them, actually, I wanted a way to, send you the first degree or the second degree right there in the template, not kind of render it here. So there is, I think it's hard, as I've seen in the company rolling this out, I think it's hard to have one ideology of like, let's do logicless. I think there are a lot of people who want to bridge that.
I agree. I don't believe in logicless either. I think you do need that. I guess I'm just wondering that, like, what if you now come, I say I want to do less than 1 or greater than 2, and now it doesn't work anymore. So.
Oh, we have a helper for that called if, where you can actually evaluate an expression.
Okay.
Yeah, you can check out our LinkedIn Dust extension site here, GitHub LinkedIn Dust.js. We do have all that open sourced. All the helpers that we use internally are right there.
And can developers easily add their own, or
Yeah.
is it kind of like you just provide?
It's a pull request. I mean, we usually have a separate file. We don't pull into every single helper that anybody contributes into our LinkedIn base. But if it's really useful, we do.
So the one thing I think JSPs did do well,
You guys can
Okay.
chat.
we'll chat later.
Okay. Sorry, guys. You should come work at LinkedIn. Thank you. Thank you so much. Thank you, guys, for letting us come and talk here.